So welcome everyone. Thanks for coming to the Luohan webinar today. And we're honored to invite Jin Liu from Princeton University to present her project on multinational production and innovation in Tandem. So without further ado, please join me in welcome Jin. And Jin, please take it away.
Great. Hi, everyone. Thank you for having me here today, and thank you all for coming to the talk. I'm very happy to share with you. This is my job market paper. It's about multinational production and innovation. And the standard data disclaimer for the US Census Bureau applies here. But without further ado, let me jump right into the motivation. So we live in the age of large-scale offshoring and onshoring of manufacturing activities. Between 1995 and 2010, there was a big trend for manufacturing production being moved from advanced economies to low-cost economies. And so the goods supplied by foreign affiliates of US firms during that period almost tripled. So did their foreign R&D expenditure. However, in recent years, this trend of increasing offshoring activities has been slowed down and even reversed as the Trump and Biden administrations made policies trying to bring manufacturing back to the US. So this has triggered some discussion on the media, arguing about whether offshoring or onshoring is better for the US economy, and we have mixed views on that. We also have very little evidence on how the offshoring of manufacturing production will affect the location of innovation, which we care about because innovation has local spillovers and social benefits. We also have little evidence on how the offshoring between two countries will affect other countries in the world. Therefore, the research questions that come out of this discussion are the following. At the micro level, when multinational firms relocate production, what happens to their location of innovation? Will they try to co-locate these two activities by moving innovation to where production goes, or will they simply choose the highest return location for innovation regardless of where they produce? Are these offshoring choices in different countries correlated with each other? So thinking about these micro-level questions will have aggregate implications because if you think about the US manufacturing reshoring policies, will that ever have any impact on the global allocation of innovation? In particular, when the US brings production back, will it also bring innovation back, or will innovation continue to stay in the host country or even move to third-party countries? Do bilateral trade policies, especially those between the US and China in the past few years, have third country effect? So in this paper, I will try to identify two missing ingredients that I think are important for answering these questions. The first is the co-location benefits between production and innovation. And the second is the cross-country interdependence in these offshoring decisions. To introduce the first ingredient, let's think about the factors that affect firms' location choices. So there exist forces that push firms to co-locate these two activities. The first is what I call the synergy effect. This captures the idea that if you locate these two teams together, they're going to have more interactions directly with reduced cost of communication and coordination. And this may spur new ideas, making the new product commercialization faster, etc. So the net effect is an increase in the efficiency of innovation. One real-life example of this synergy effect is the Gigafactory of Elon Musk's. In this quote, you can see that Elon Musk asks his design engineers to move their desks right next to the assembly line so they can observe actually what's going to be produced and how. Another example is a US manufacturing firm, Texas Instruments, which start up their R&D lab and production facility both in Singapore because the trial testing of new generations of chips requires close collaboration of these two teams. So This is the synergy effect, but on top of that, there is another co-location force, which can be the potential cost sharing. This captures the idea that having local production may reduce the fixed cost of innovation because these two teams can share overhead expenses such as rent and management resources. However, in the other direction, there also exist forces that push firms to separate production and innovation in different countries. And the biggest reason for that is that countries have comparative advantages. The countries that have the lowest production cost are usually not countries that have high returns to innovation. This is why we see companies like Apple and Dyson that locate production in low-cost countries like China and Malaysia, while locating innovation in high-return countries like the US and the UK. So this kind of separation force has been understood in the literature. What's still missing is whether there exists co-location benefits, and if so, how large are they? So this is going to be the first thing we look at in the paper. Learning about these co-location benefits is going to tell us how production and innovation move between the home country and the host country. But that's not enough for answering our questions, as there is another possibility that these activities will flow to third-party countries. And this is actually what has happened in the past. In the recent years, due to the US-China trade tensions, many firms have relocated their activities away from China towards other East Asian countries. So in the table, you can see a list of companies that have relocated to countries like Indonesia, Vietnam, Thailand, and Philippines. And why do they relocate still within the same region? It's partially because there exists regional complementarities. So many of these firms set up regional R&D center, say in Singapore, to support its entire production and marketing for the East Asian region. And sometimes different affiliates in different locations share the same management team and even legal service provider. So all of these anecdotes seem to suggest that these offshoring choices in different countries are correlated with each other. However, in previous literature, many models have assumed that firms make independent offshoring decisions in each country. And that is due to technical simplicity. However, if we make that assumption, then bilateral trade policies will not have flexible third country effects. Therefore, in this paper, I would like to argue that it's important to take into account cross-country interdependencies. And I will be having three sources of interdependencies. So the first one is the regional cost sharing effect, which says that the fixed cost of innovation will be lower when the firm has production in neighboring countries. In addition to that, there are two global forces. One is input substitutability. So say a firm produces more in Korea, then it may want to produce less in Japan because the products are substitutable with each other. That creates a negative correlation across these two locations. But there also exists a scale effect that creates a positive correlation. So when the firm produces more in Korea, it's going to have lower marginal cost at the firm level, and the firm is going to expand in size, making it more profitable to start production in Japan. So there do exist both negative and positive forces, and it remains an empirical question of which one is dominant. I will be showing you two pieces of evidence that in reality, on average, it's the positive scale effect that is stronger. Therefore, the model features net complementarity, and that is very helpful for a solution algorithm. But before going there, let me tell you about the causal evidence for why I think these two ingredients matter. So here I use variations from tariffs, trying to establish a causal effect of offshore production on offshore innovation. So here, the idea is that these tariffs affect the cost of shipping goods across borders. So they affect the cost of offshoring production, but they should not have a direct impact on these firms' foreign R&D expenditure. If we see an impact of tariffs on foreign R&D expenditure, we should be able to infer an intermediation effect of production on innovation. That's the idea. Then what I found is that when the US import tariff increases for a host country, then US firms would reduce their offshore production and innovation, not only in that host country itself, but also in neighboring countries of the same region. So these two pieces of evidence support the presence of within-country co-location benefits and cross-country interdependence that is positive. The next goal is to develop a quantitative framework that we can use to think about counterfactual trade policies after taking into account these two forces. So I will be showing you a framework that features a dynamic knowledge production process in the sense that a multinational firm's productivity is going to evolve based on its innovation efforts at each location, as well as the proximity between production and innovation. Then I will allow countries to have comparative advantages flexibly in terms of the production cost and the returns to innovation. So the challenge of trying to model interdependence is that we now have a permutation problem. The firm now needs to simultaneously consider all the possible combinations of countries. And if we have 40 countries in the data, then it's going to be 2 to the power of 40 many points, both in the action space and in the state space. So that is computationally super challenging. And my approach to a solution involves 2 steps. In the first step, I will assign these interdependence forces in my model and show that a net is the positive forces that's dominant. Therefore, the model features a property called supermodularity. Then in the second step, this property is going to help us to apply a squeezing algorithm to solve this combinatorial discrete choice problem efficiently. So that's the roadmap. Then what did I find from solving this complicated model? The main estimation result is that when the firm offshores only innovation, there is not much benefit to that. But if the firm offshores both production and innovation simultaneously, then it's going to have a larger productivity increase in the subsequent period. So this is saying innovation is more efficient when it's accompanied by production. Then having this estimated model, I will be conducting several counterfactual exercises, basically trying to think about US and China bilateral trade policies that makes it more costly for US firms to produce in China. And I found that when the US firms brings production back, the reshoring of innovation is quite limited. However, the effect on third-party countries can be substantial. Sometimes it's as large as the impact on directly impacted countries, which is China and the US. And then I also find nonlinear effect when we vary the size of the policy. This is because there is a lot of firm heterogeneity in terms of where and what they offshore, and different trade policies affect different groups of firms relatively more. Finally, I will demonstrate that this framework is able to speak to dynamic effects of trade shocks. And this is because of the endogenous innovation and productivity process. All right, let me save some time by skipping the literature, and let's look at the data and descriptives. So I'm using the administrative data from the US Census Bureau between 2008 and 2019. The most important data set is their business R&D survey, in which I discovered a previously underused survey module that asks firms about their total R&D expenditure, as well as a breakdown of that expenditure by location. So for instance, suppose Apple is in the sample, then I can see how much Apple spends on R&D in the US versus France versus China, etc. So that is a very scarce source of information. On top of that, I rely on the FTTD data to observe the import transactions for US firms. Then the Census of Manufacturing and the Annual Survey of Manufacturers provide additional variables that are useful for production function estimation. Then at this point, I do want to tell you about one data caveat, which is that because I don't observe the foreign affiliate operations, what I do is to use a firm's imports from a foreign country to proxy for the firm's offshore production to that country. So of course, imports and offshore production are not the same, but I showed that they track each other pretty well, both in terms of levels and growth rate. And I have done a lot of robustness tests, including using only related party trade as a proxy for offshore production. But after doing this and combining several data sets, I was able to get an unbalanced panel. But luckily, large firms that account for the majority of the activities are surveyed almost every year. And among firms that do perform R&D, offshore R&D is non-trivial. It accounts for 1/4 of total firm-wide R&D. It's also important to think about multiple offshoring destinations for firms because multi-location firms account for the most of these offshore activities. So to put it to concrete numbers, firms that have more than 10 foreign R&D locations account for 70% of offshore R&D, and firms that import from more than 10 countries account for almost all of these import value. So that is saying there are a small number of multi-location firms, but these are super big firms that account for the majority of offshoring activities. Therefore, it's important to model their location decisions. Then another interesting statistic is that 94% of foreign R&D expenditure is actually spent in countries where the firm also has imports. Only 6% of foreign innovation is conducted without the accompany of our proxy for production. So this is actually an important pattern that's driving the main estimation result. All right, now let me show you some collocation pattern at the country level. In the blue map, I'm plotting the US firms' offshore production in 2017, and the green map corresponds to their offshore innovation. So we see that these two maps seem to have very similar geographical patterns. And in fact, if we plot them in the same scatter graph, we see that there is a clear positive correlation, meaning that big destinations for offshore production are also big destinations for offshore innovation. So the top destinations for US innovation include countries such as Japan, China, Israel, and that for production include China, Canada, Mexico, for instance. So there is a significant overlapping of these two lists, which means there might exist huge collocation benefits, but there is also a significant discrepancy of these two lists, which implies that countries have comparative advantages in production and innovation. So that is the country level fact for collocation, but this fact can either be explained by an intrinsic relationship between production and innovation, which is what we wanted, but this can also be confounded by country characteristics and their correlation. Therefore, the next step is to move to causality, where I want to use variation from tariffs to show you a causal effect of offshore production on offshore innovation. So there is an endogeneity issue when we run regressions at the firm and country level. And that is because we have affiliate unobservables. So suppose I run a Chinese affiliate of a US multinational firm, then suppose I have a better manager in this affiliation, then I will see both increased production and increased innovation for that reason. But this is creating some positive bias for our estimate of collocation benefits. Therefore, in the paper, I have done two identification strategies. The first is to exploit Trump tariffs as a natural experiment. And the second strategy is to construct a shift share style firm country year specific tariff rate and use that as an instrument for offshore production. But for the sake of time, I will be focusing on the first strategy today, but briefly talk you through the result of the second strategy as well. So the Trump tariffs is a series of tariff increases targeted on some country product pairs starting from 2018. And there were multiple waves and some special products involved. So the trade war started from solar panels and washing machines. It got expanded to metals and then later on to a broader set of products. So China has been a main target of this tariff policy. More than half of the imposed tariff lines were on Chinese products, but there also exist a lot of tariff lines for other countries. So one thing I want to highlight is that these estimate for collocation benefits are actually robust after removing China from the regression sample. But how did I define the treated and control units then? I first obtained a list of country product pairs that were targets of the Trump tariffs. Then based on the LFTTD, I was able to observe the list of product that each firm used to import from each country. So suppose any of the goods that the firm I used to import from country L became a target of this Trump tariff policy, then this firm country pair goes into the treatment group. If none of the product that the firm used to import was affected by tariffs, then this firm country pair is in the control group. But then the study sample consists of all the firm country pairs for which the import value was positive in the prior period. So this somehow limits the sample size. In terms of regression specification, I'm regressing the outcome variables Y on the interaction of treatment dummy and year dummies, controlling for firm country year fixed effect, as well as firm year level control variables, most importantly, firm revenue and employment size. So because of the country year fixed effect, I'm effectively comparing different affiliates of different US multinational firms located in the same host country. So one of these affiliates became affected because of its import product bundle in the prior period, and the other was not affected. So the identification assumption is that these random tariff shocks based on the firm's ex-ante import product bundle should not be correlated with affiliate unobservables that affect the changes in innovation, for instance, the change in management skills. Then here is the result from event study regressions. We see that the treated units are associated with a reduction in import and innovation, both in terms of the likelihood of doing innovation and conditioning on still doing innovation. There is a reduction on the amount of R&D expenditure. And this result is robust to removing China from the sample, removing semiconductor industry, using only related party trade in as opposed to the sum of related party trade and arm's length trade. This is also robust to using alternative continuous measures of the intensity of treatment, etc. So that is the first strategy. Then the second strategy involves an instrument for offshore production. This is less restrictive in terms of sample size, which means I can include richer fixed effect at the firm year level for confounding factors. But despite these specification differences, the good news is that we have the same result. Higher tariffs leads to a reduction in import and innovation in the host country. But what's even more interesting is that we now have evidence for interdependence. So here, I'm trying to ask the question of whether tariffs in neighboring countries also have a negative impact on the offshore production and innovation in the host country. And the answer is yes. And we see that the regional tariff term also has a negative and significant impact. So this is saying when the US impose higher tariffs on China, then US firms reduce their activities not only in China, but also in Japan. So this hints on the cross-country interdependence with a positive sign. All right, so let's take stock of the reduced form analysis and move on to structural model. So there are two main takeaways or results from the causal analysis. One is that offshore production has a positive impact on offshore innovation in the host country, and that corresponds to co-location benefits. The second result is that offshore production also has a positive impact on innovation in neighboring countries, and that corresponds to why we model cross-country interdependence. Then to fix ideas for the model, let's think about a US firm and some foreign countries. The firm is going to choose a set of countries in which to produce parts, and the produced parts will be imported back to the US as intermediates. Then the firm is also going to choose another set of countries to do innovation. And the innovation effort is going to affect the future productivity of the firm. Then the firm combines the imported intermediates with the current level of productivity to produce a final product that will be sold to the global market. So that is the structure of production. In terms of market structure, the demand is monopolistically competitive. So the firm demand depends on the industry demand shifter and negatively on its own price. Eta is the demand elasticity. Then I assume the unit production cost to be constant and varies with a few cost shifters, including the firm's capital stock, the wage level in the industry, the price index for imported intermediate, and the firm's productivity. So both the intermediate price and firm productivity are going to be endogenously determined by the firm's location choices. So the imported intermediates will be combined together in the CES way, and rho will be the elasticity of substitution between these goods. And this is the parameter that corresponds to the negative substitutability effect that we mentioned in the introduction. Then the cost of obtaining 1 unit of imported goods from a foreign country depends on foreign wage level, the shipping costs between the US and that country, as well as the import tariff. Then because of the CES structure, the price index for imports has the following format, where I want to highlight the green term theta LT, which varies at the country year level. So this captures kind of how costly it is for firms to obtain goods from this foreign country. So you can think of this as production cost after taking into account trade and shipping cost. Then here is R&D and how that affects productivity. So here omega is from ICE productivity that follows a Markov process. So the shift is going to depend on the firm's location choices. If you look at the green terms, RILT is an indicator for whether firm I offshores innovation to country L, and YILT is the same indicator for offshore production. So if the firm offshores innovation to one more country, its next period's productivity is going to increase by beta 1. So this is the return to standalone innovation. Then if the firm also offshores production together with innovation, there is an additional increase of beta 2. So this captures the synergy effect, the increase in innovation efficiency when innovation is accompanied by production. Then I also allow for a direct effect of production, which is beta 3. This is capturing kind of the learning by importing type of effect. But so far, these green terms are common to all countries in order to allow for the returns to innovation to be different across countries. I'm including this orange term, which is country-specific multiplier. That is a projection onto a vector of country characteristics, X. Basically, X includes country's income level, population, human capital stock, etc. So a bunch of factors that affect the innovation return. Finally, Kasai IT is a normal shock that captures the randomness in innovation. Then dynamically, the firm needs to pay fixed and sunk cost for offshoring, and things are pretty standard here, except that I allow the fixed cost of innovation to be lowered by lambda 1 if the firm has production in the region. This is capturing the cost sharing effect, and lambda 1 is the parameter that's governing this effect. All right, so here is the dynamic programming problem of the firm. In the state vector S, we have the firm's past location choice bundle for production and innovation, and this period's productivity. Based on this state vector, the firm is going to choose the current location bundle for production YIT and the current location bundle for innovation RIT in order to maximize static profit net of offshoring cost plus continuation value. So I want to highlight two things for this equation. First is that there is actually rich trade geography behind this dynamic programming problem. So countries have different production costs combined with the firm's endogenous choice of production locations. They're going to affect the import price, which enters through the static profit here. Then countries also have different returns to innovation, combined with the firm's choice of innovation locations are going to affect the next period's productivity of the firm, which affect the continuation value. Then there is also regional cost sharing effect that's entering through the fixed cost term in green. So that's one thing. Another point I want to highlight is that actually this equation looks simple, but it's super difficult to solve because both in the state space S and in the action space Y and RIT, we have all the possible combinations of countries. So these two spaces include more than 2 to the power of 40 many points. So it's like hard to solve this problem in brute force. That's why I'm approaching this problem with a supermodularity property and a subsequent squeezing algorithm. So to briefly explain this supermodularity property, so I have established a theorem that says, suppose we have some regularity conditions and we have this inequality condition, then we can show that the firm's lifetime objective function is supermodular in its lifetime policy function or decision rule. And so this supermodularity sounds a bit technical at first sight, but it simply translates into many complementarities. So let me walk you through these complementarity forces. First of all, production in this period is complementary to production next period, because once we start production, the next period we have to pay the lower fixed cost rather than the higher sunk cost. So this means offshoring today makes it cheaper to continue offshore tomorrow. And the same is true for innovation. So there is dynamic complementarity in that sense. Then production and innovation are complementary when they are in the same host country and when they are in neighboring countries. This is because we have built in this synergy effect and regional cost sharing effect. Then finally, production in two different countries will be complementary when the positive scale effect is stronger than the negative substitution effect, which is essentially what this inequality condition requires. But because the model has a lot of net complementarities, both statically and dynamically, it has a lattice structure called supermodularity. And this is very useful because we can then apply a squeezing algorithm to solve this problem in a couple of minutes, basically. So I don't want to bother you with too many details about this algorithm, but I do want to highlight three key ideas behind it, because I think these ideas can be useful in other contexts too. So the first idea is when we have a large, complicated problem involving decisions in multiple countries, then sometimes it's useful to break it down into many single country problems. The benefit is that each single country problem is then easy to solve with a small state and action space. And we can iterate over these single country problems. When we solve for each of these single country problem, we fix the choices in other countries at their bounds. So this is similar intuition as in previous static algorithms. For instance, Pan-Le-Jia's paper on the penetration of Walmart. The second idea is that when we solve the problem for the current state, we actually don't need full information on the payoffs in other state. Sometimes partial information is sufficient to inform our current decision. For instance, if I'm trying to decide whether I should invest today, and suppose I know that my payoff in every future period is going to be above certain threshold, then I know that my payoff is big enough so that I should be investing today, even though I don't know the exact value of the payoffs in future periods. So this kind of idea enables us to track only bounds on the optimal choices without the need to save the entire policy function, which is a huge map from the large state space to the large action space. The last idea is that this algorithm is designed in a way that we don't need to solve for the problems along every possible paths. Instead, we can focus on three specific paths, one corresponding to the upper bound, one corresponding to the lower bound, and one corresponding to the simulated shocks that we're interested in. So this hugely reduces the number of problems that we need to solve. I'm happy to talk about this more if you are interested, but now let's jump to estimation, and let me tell you about the policy implications. So this is a list of parameters that we need to estimate for the model, and there are 3 steps for estimation. In the first step, I start from this equation, this relationship between the value share of a firm's imports and the country level production cost, basically. So I obtain a linear equation that can be estimated using OLS, basically. So the theta LT will be the country's offshore production offshoring potential. You can think of these as production cost of country L, and they can be backed out using fixed effect at the country year level. So here I cross-validate the estimate of theta LT against the number of US firms that import from each of these countries. So they have a clear positive correlation, which is reassuring. And then China and Canada are estimated to have the largest production offshoring potential or the lowest production cost taking into account trade cost. And China is there because many of the low labor cost. And Canada is estimated to have high potential because of the proximity with the US and the low trading cost. Then in the second step, I try to estimate the production function and the productivity evolution process. So here the standard endogeneity issue coming from zero correlation exists, and I apply the kind of also standard IO approach for production function estimation, which is using the energy input as a control for the intrinsic productivity. So I'll skip the econometric details, but tell you the estimation result. So here we should be looking at the returns to innovation. So beta 1 is the return to standalone innovation, which is estimated to be close to 0. And beta 2 is the return to co-located innovation and production corresponding to the synergy effect. This is positive and significant. Then beta 3 is the learning by importing kind of effect, which is also positive. So the most important takeaway is the positive estimate of beta 2, which says that innovation is more efficient when it's accompanied by production. All right, so in the last step, I'm matching moments informed by the average probability of offshore production and innovation, and I'm using that to back out the fixed and sunk cost for offshoring. So things are pretty reasonable, and the estimate for innovation, for the fixed cost of innovation, is very similar to the average annual R&D expenditure of these firms in my summary statistic. So right after estimation, I try to validate this model by simulating the exact Trump tariffs policy in my model. And I find that this can generate the right magnitude of effect compared to my AVI estimates. So this is kind of reassuring. Then I try to understand the relative importance of the two co-location benefits, basically the synergy effect versus the cost sharing effect. What I did is to individually shut down these two effects and see what it's going to do to the model in terms of the offshore probability and the collocation pattern. So I found that when I shut down the synergy effect, it's going to have a huge impact on the model simulation result. When I shut down the cost sharing effect, there is minimal impact. So the takeaway is that synergy effect actually matters more. And the biggest reason why firms want to co-locate production and innovation is because they want to have larger productivity gain rather than to save overhead expenses. Then let's spend the last 10 to 15 minutes talking about the counterfactual exercises. So here I'm trying to think about the bilateral trade policies between the US and China that makes it harder for US firms to produce in China. And this can be implemented in two ways in the model, either by increasing US tariff on Chinese goods or by directly increasing the fixed cost for production in China. And I find that consistently across these different exercises, all countries will have lower production and innovation when there is a negative trade shock because of the supermodularity property. Then in terms of the relative changes, when the US increases production shares, the increase in its innovation share is going to be limited. And there are like two reasons for that. The first reason is the third country effect. So part of the R&D that was forced to leave China actually did not come back to the US. Instead, it gets diverted to other third-party countries like France and Mexico, because these countries offer a competitive bundle of low production cost and relatively high return to innovation. Another reason is a scale effect. So despite the co-location benefits, many firms used to produce in China but not innovate there. They innovate in other high return countries such as the US. And then when these firms are hit with a negative shock, they scale down globally, meaning that they also reduce their innovation in the US. And this reduction partially offsets the reshoring of manufacturing innovation to the US, which is why together they explain the limited increase in US innovation share. But that also implies that it's important to look at firm heterogeneity. So here I'm categorizing US firms based on their productivity deciles on the x-axis and the capital stock deciles on the y-axis. So here the upper right corner correspond to firms that have the most capital and the largest firms, basically. So the blue shadow indicates their probability of offshore production to China and the rest of the world. The red shadow corresponds to their innovation probability. So we see that the largest firms do offshore both production and innovation to China and many other countries. But the medium-sized firms offshore production to China, but they don't innovate there. Instead, they innovate in other countries, including the US. So when a moderate trade shock happens, then these medium-sized firms is going to reduce their production in China. They have no innovation there to reduce, but they will reduce innovation elsewhere. So the net effect is an increase in China's innovation share in the global economy, which is kind of counterintuitive at first sight. But then when we change the size of the policy, making it stronger and stronger, and even moving to the extreme case of full decoupling between the US and China, then even the largest firms that used to also innovate in China starts to get impacted. That's when China's share in global innovation is going to decrease. And this is basically the reason for the nonlinear effect. And it kind of implies the importance of taking into account firm heterogeneity, because these US firms are very different in terms of what and where they offshore, and different sizes of the policies will affect different groups of firms relatively more. All right, so the last exercise is trying to demonstrate that this framework is able to speak to dynamic effects of trade policies. So here I simulated some negative shocks to China's production offshoring potential. And I find that after having, say, higher tariffs, US firms is going to reduce offshoring activities globally. And this implies higher prices for imported intermediates, higher marginal cost, and lower profit. But these kind of effects are standard static losses. What's more interesting from this framework is that there is dynamic losses from the trade shocks. So the story is that suppose the US firms now have less offshore production and innovation, this is going to translate into lower future productivity due to the Markov process. And the lowered productivity implies a smaller scale of the firm. And the smaller scale then further implies that it's more difficult for the firm to overcome the fixed cost of offshoring, which further exacerbates the reduction in offshoring activities. So this kind of negative feedback loop goes on and on. That's why the losses from negative trade shocks accumulates over time. In terms of the magnitude, the productivity loss starts from almost zero right after the shock, but it gets accumulated to 0.4% over 10 years. So it's not a huge dynamic effect, but the point is that this framework is able to speak to these kind of dynamic effects, which may be important in other contexts. And this is because of our endogenous modeling of the innovation process and productivity change. All right, so that's the last counterfactual. Let me now conclude and mention some potential future work. So in this paper, I study the multinational firms' location choices for production and innovation, and I find both complementarities within a host country and across host countries within a region. Then I use a structural model to think about bilateral trade policies and find that it's important to consider the effect of bilateral trade policies on third-party countries. It's also important to take into account firm heterogeneity because they're going to imply nonlinear effect for different policies. Then there is also an important dimension, which is the dynamic effect of trade policies, which is kind of absent in a lot of general equilibrium trade models. In terms of potential extension to this work, it's kind of important to think about the different types of innovation, the process versus product innovation, and how the distance between production and innovation matters differentially for different types of innovation. Suppose we find that co-location benefit is larger for process innovation than product innovation. Then this implies that whatever trade policy that affects firms' location choices is also going to have an implication for the direction of technology change. Another interesting fact that I found from reading a book is that actually a lot of firms might be underestimating their synergy effect. So it's when the firm considers offshoring manufacturing to foreign countries, then what they typically do is to hire an accounting firm to do the cost benefit analysis. So it's so easy for them to realize like how much cost they will be saving by offshoring production to China, but it's less obvious and more subtle for them to realize that actually by offshoring, they will be losing the synergy effect. They will be having a lower innovation efficiency. And if this is actually the case, then what I should be having in the model is two levels of beta 2, one governing the actual evolution process, and the other is what firm perceives the synergy effect to be. And I'm trying to learn from another IO literature, trying to separately identify these two levels of beta 2. If they are indeed very different, it means firms are underestimating the main force in practice. And simply by telling firms, hey, you're ignoring this synergy effect, they should be doing something differently. All right, so that's all I want to say for this project. Thank you for listening.
Thanks so much, Jane. It's so amazing and it's super helpful to see both the new empirical results and also especially new structural model improvement in this very important question. So I do have some questions to ask. I can also open the floor to the audience. Everyone, if you want to ask questions, please feel free to jump in and or raise hands at any time. Okay. Maybe I can start with one quick question, a little bit more high level question. I think the empirical part is super clear, which we see these two very clear pattern. One is that production allocation super positively correlate with their innovation location, and also when there is negative shock on the production location due to the tariff, and the firms also spend less on R&D in that country specifically. And then when we move to the model, actually we focus on this two very specific mechanism, which is synergy, and also the cost sharing, especially the fixed cost sharing, and also more standard production substitutability and increasing return to scale due to this production function. So I think my high-level question is, should we think of these two mechanisms like synergy and cost sharing are the two key assumptions in this model? And how should we think about that other potential mechanism? So for example, even for this cost sharing mechanism, for example, my understanding currently is modeled as more like fixed cost way. That's how the model built into it. But we can also potentially look at in a variable cost way, or so basically many other potential mechanisms. How should we think about like how high level? I think can even decompose in two questions. One is that when we choose to focus on these two mechanisms, do we think there is some empirical support that lead us to focus on these two mechanisms? And second, how do you think about other potential mechanism or other ways to model this two in the model?
Thank you. Thank you. That's very helpful question. So for the first part, why do I model the cost sharing as sharing the fixed cost rather than variable cost? This is actually because I'm modeling the discrete choices. So there is only extensive margin of innovation, whether I do innovation in this country or not. There is no intensive margin because it's kind of impossible to model intensive margin with interdependence across countries. So because I only have the extensive margin of innovation, it's natural that fixed cost is going to matter. And there is no concept of variable cost in this framework. But if you do have both margins, then it would be interesting to differentiate whether the co-location matters more for fixed cost versus variable cost. So that is like an interesting question beyond the scope. Another thing is like, why do we focus on the synergy effect and cost sharing effect rather than other potential mechanisms? So it's actually not by assumption that we will be having synergy and cost sharing effect. It's more working like I allow my model to have these two forces, and then I use data patterns trying to back out these two mechanisms. It's totally possible that the data estimation implies that none of these mechanisms matters and it could be something else. But this is like an estimation result rather than assumption, according to my understanding. And the synergy effect actually is estimated to be stronger than the cost sharing effect, which is more reassuring because the estimate of the synergy effect actually follows a lot of the previous literature on the production function estimation. So there is like solid econometric tools behind it. So it's more like estimation result. If that answers the question.
Yeah, this is super helpful. So we can also open the floor for audience. If anyone wants to ask questions, please join us or raise hands.
Hi, Jin.
Hi.
Can you hear?
Yes.
Hi.
Yes.
Yeah, thank you so much for sharing this work with us. It's really extensive work, and you presenting a really short period of time, so it's a lot to take in. And also I have a couple of related questions. Maybe start from the paper itself. You showed a graph where you looked at cross-country correlation between production and innovation. And if I'm not mistaken, on the top far right, you see countries like China, and also I think also saw the Netherlands there. It's a bit surprising because the country I'm not too sure they manufacture much. I mean, Germany sure is a big manufacturer, right? So I'm curious in the sense that I suppose when you plot the graph, you use the values, right? The R&D investment values versus production values, I suppose.
Yes.
So I'm just curious, wouldn't it be more accurate or more appropriate if you look at the share? So you renormalize by the total production of the firm, and then you see, okay, what's the share of the Netherlands in the total production of the company? And what is the R&D investment of the Netherlands in the total R&D investment of the company? So everything is normalized to one. And then you look at that correlation, And I guess if you do that, the graph might look quite different. And to me, that might be more appropriate to look at when you see. So in a way, you're looking at production intensity versus R&D intensity by country. And I'm not too sure whether a different picture will emerge. And also, when you do this cross-country correlation, does it differ a lot across different years? Because I suppose you picked 1 year, and I don't know
Yes,
which.
this is 2017, but it's actually super robust if I use
Right.
another year. And I'm actually not quite understanding, like when you say if I put shares, would it just be like a different scaling?
Yeah, because in that sense, I think if you look at production intensity versus R&D intensity, and I guess that would give you a more accurate representation of the exact to what extent this firm is actually engaged in production in certain country and engaged in R&D in certain country. Because now if you look at the value and you also scaled, I think you used the log, right?
Yeah.
So basically the puzzle comes from the fact that Netherlands is really high in the top far right, and the country, to my intuition, shouldn't have so much production. So that's sort of where the puzzle comes from. And also the
Yeah,
other
I
point,
could double check that, but
yeah,
maybe it's useful to mention that in the estimation, I do use shares rather than the absolute levels. It's only in this graph, it's showing
right,
you absolute values, but I could double check.
right. And the other question I have is that in one of the graphs you showed in the structural model, I think, where you said the country, they may have production or OEM in other countries, and they import back intermediates. Often when you have OEM factories in foreign countries, it's most of the cases, I think they will finish the whole production, right? They ship the product back rather than importing intermediates. I mean, in the real world, like China is a typical case where you have a lot of OEM factories. And normally when they are engaged in production, they finish the whole product, right? Rather than producing a certain part and then ship it back to the US, for instance, for the final production or assembly. So
Yeah,
yeah,
so it's kind of an important fact, but in the data, it's like half of the US imports are from intermediary goods, and the remaining shares are for final goods. So you're definitely right that my framework is more suitable to talk about the
yeah,
kind of intermediary production rather
yeah,
than this kind of OEM that
exactly.
produces the
Yeah.
final goods. Definitely.
Yeah, right. Yeah. And maybe a final comment that I have is that take the findings as they are. When you have this protectionist trade policy, then your findings suggest that there will be a decline in R&D activities basically across the world, right? I'm just curious that whether it's included or you thought about, instead of looking at R&D investment by country, perhaps you could also try and look at the patent data of the company in the host country. I mean, R&D is sort of an input measure, right? And then we have the patent data that's sort of more like a output measure, and it's also richer in the sense that when you have the patent data, you could really look at what type of innovation they are engaged in across these countries. Because when you look at R&D investment, just a number, and that doesn't give you much information across countries, just a number, big or small, right? But if you also look at patent data, that's a lot richer information. I think you can explore a lot of, heterogeneities and other things in the data. And that might be more, the findings will be more granular, let's say.
Yeah, that's a very good suggestion. I've been thinking about that a lot, actually. One potential issue with using patent data is that we don't know whether the location where the firm files the patent is necessarily the location where
Right.
the firm conducts innovation. They can be super different, and the firm might be strategically choosing the location for patenting for tax evasion kind of incentives. So there
Right.
is more of that issue there. But despite this issue, I think it's super useful if we bring in patent data, because as I hinted at the last slide, we can differentiating between product versus process innovation. We
Yeah.
can identify like groundbreaking innovation versus marginal innovation to have a more comprehensive view of the multinational innovation. But the challenge is more like I need to bring this patent data to merge it with the US Census Bureau data, which is super heavily
Yeah.
administratively difficult. So that is like kind of the data challenge. I would ideally want to do that for sure.
Right. Yeah. Thanks.
Thanks for the questions.
Yes. Okay. Thanks so much, Jane, for joining us today and giving this amazing presentation. I personally learned so much and really interested in this topic. And we look forward to seeing you all in future webinars and the Luohan events. And thank you all for joining us today.
Thank you for coming, and I'm happy to discuss if you want to talk. Please just email me.